go through it. Let's just get into it. So we start off with Google and we start by searching Raavann.com. Press enter. This is our website. We have two modes on the website, dark mode and light mode. So we can turn off the switch or turn on the switch over here. And here we can put in whatever our query is. So the product is designed for deep research. So we only entertain the search queries which require a lot of research, lot of thinking, lot of going into depths, those kind of things. So we just start off with, for example, I want to compare single agent LLMs with multi-agent LLMs. I want to know which LLM, okay, is suitable for handling deep, complex queries. And we click on dive. This is our diver. We click on it and it asks us which mode do you want? Okay, so there are a few options. One is team of research experts. So instead of just one person researching on your topic, we design a whole orchestra. So we have a like a kind of a research lab working for you, and like an analogy. And the other mode we have is lone scout. That is single researcher researching. The lone scout is suitable if you want something quick, like a smart, like a very short specific query that you have, that you want a quick answer for. That's lone scout for. But most of the people that in terms of testing, what they have liked is um, uh, expedition crew for literature review and for long form research, something that requires a lot of reasoning, lot of research, and something that is very quick and they just want to know it quickly, but it's very difficult, or it will take a lot of time on the existing LLMs to get the output. They choose the lone scout for that. So let's start off with expedition crew. And as you can see, the layout of the product is quite different. It's not like ChatGPT or the existing LLMs out there. And the reason is because we believe design should follow the function. So the function in our case is deep research. So when it is for deep research, we cannot design it like a chatbot or a typical generative AI product. Cannot be that. So in our case, because the user is willing to go into depths, it researches a lot. So we cannot do it like a small research or like a quick research. We need to do a lot of research to get the concrete understanding of the subject. To do that, what we have done is we have designed the architecture where you can see there are six researchers working on a single prompt. I just asked for a comparison of single agent and multi-agent, and we have six researchers who are working for this prompt. So as you can see, we have paradigm researcher, architecture researcher, evaluation researcher, and three below. All of these researchers, for example, architecture researcher starts off with to get a general overview of the core architectural components, coordination mechanism, internal workflows. It will do some reading of research papers and online content. It will read it. It will understand how the current architectures are working. Now, based on that reading, it will understand, okay, these are the things that are missing. We need to do this. So then it will research some more. Then again, from that feedback, like the way a typical human learns a subject, it reads, it understands, and it decides, okay, we need to course correct over that. The thing is, course correction in all of these researchers is based on our preloaded frameworks, because we have been doing this for quite some time, and because of those entities I mentioned, that the connections we have, the things that it will research, it will decide to research on, will be totally different than the existing LLMs, because again, they don't have those entities, they don't have those connections. So now the output will be very long. It's a concrete, it's because the research was too much. Like as you can see, 172 research papers was read in this just few seconds, and 266 websites, articles, those kind of things were read. So yeah, so research was a quite long research, and for that amount of research, you can see the time was pretty less. So till the time the output gets loaded, I have the a sample. Like I gave the same prompt a bit earlier, so I can show you the output that I got at that time. So, for example, okay, so what is this? So this is basically my dives. So we are on the landing page and this is our my dives. So what is my dives? My dives is basically our past research that we did on Raavann. It's like a history. But the way to, again, as mentioned, design should follow the function. The history, you cannot just say this is what you research. No, because we know that people over here are willing to go into depths, the history should look in a certain way. Okay, as of now, this won't look like a big deal, but I'll show you why we have designed the history like it in few minutes. So okay, so we look at this and we look what have we researched. Now as you can see, like this is a bit of a thing that I mentioned earlier, because so I researched this, and while reading it I found something that I want to go deep on, and I clicked on it and I went deep on that topic. So even that topic is added as a node in this history. So I click over here, I go back to where I was in terms of the output and the whole thing. So okay, I have the whole output ready. Again, the prompt is the same, the compare single agent LLM with multi-agent, and which architecture is best to handle complex queries. As you can see, now I'm just going over here and I'm going down. You can see how big the output is. Okay. And not even one line of this output is generic. You can see there is a lot of equations. Like it's not just like a text-based answer. It has a lot of things, and none of it is generic. Everything is very, very complex, and it's given, like for example, over here you can see number of tokens that will be taken in both architectures. So you can even understand it is comparing to the tokens level, trade-off curves between quality and efficiency. So it is comparing even that. So as mentioned, it goes to like a very deep, and even now you can see the output is not completed. So now the output is completed. Okay, along with risk mitigation strategy. But okay, we can skim through it from the start, from the top, not fully, but yeah. So as you can see, we start off with what the architectures are, how it is working, then empirical performance on complex tasks. Now, as mentioned earlier, none of it is generic. As you can see, the same multi-agent system, again, for example, this multi-agent system achieved 91.5% accuracy on GSM 8K, surpassing prior methods by 5.6 with Llama on 3.170 billion parameters, and scored 30.4%. Now, this thing is took from some research paper. Now, this research paper, you can see we put everything like the source and everything is crystal is like transparent. We don't keep it, we don't hide it. So because it's for research, so there is no point in they prefer the more transparent it is, the better it is to go deeper. Like you can the course correct more. So yeah, so it is way easier for that. And also if I want to read more, I can just go over there and complete my reading. So this is as you can see multiple mathematical like the equations, and many of the contents over here, like for example, multi-query agent, multi-query attention reduces kv cache size by share. Okay, now this thing I can assure you, this one was we got it from the entity, like the relation of the entities, because this thing, the kv cache size by sharing kv matrices across attention heads, improving speed and memory efficiency. So those connections and among the thing I mentioned in the business plan allowed us to give this kind of information. This is what the researchers are liking. This is what I like, to be honest. And okay, so this was the findings. So you in the findings you can view what is happening with the software, what's the equation, strengths and limitations, optimization techniques for complex queries. You can see core characteristics of multi-agent LLMs, like how does it work to the whole like, to the granular level, peer-to-peer and decentralized coordination. Like how does it work mathematically? Everything, communication and negotiation protocols, trade-offs, performance, latency. It gives Google's research football. You can see there might be some Google research that was done on this topic. So it is even referencing that uh, it- everything is in detail. You can see evaluation metrics, comparative analysis. It's a whole detail. Okay, we don't even stop here. What we do, this was the findings. Now we know that on this topic, like multi-agent and single agent comparison, there were a lot of experiments executed by the researchers that they have not put on the internet by labeling as experiments. They have done it, but they haven't labeled it as an experiment. So or it might be that the experiment is in the, for example, finance paper. So they haven't mentioned, even though they are doing AI experiments, it is not mentioned, it is not inside an AI paper. So it's very difficult to find on the internet because it might be in some HSBC paper. So, but because we do the relations, we can find it. So all the observations that we found from the those entities, those relationships, is right in this observation section. We can look through it, like what it is. Like you can see a lot of observations, a lot of data, and each one is, for example, in legal subsumption, DeepSeek R1, a single LLM, achieved a 91% recall for void clauses when using examination guidelines, far surpassing other models, averaging around 30%. However, its recall for valid clauses were a record low of 27%, leading to lower overall F1 scores. So those were some numerical insights. Below that, we have the textual insights. So multi-agent systems are better suited for complex queries because they enable task decomposition, agent level specialization, everything. And everything is cited. None of it is we are seeing it like none of it is we don't have anything known as hallucination. We have taken care of it fully because everything is cited and it doesn't work without citation. And yeah, so all those data, now we can see patterns in in those relationships. Even we go even deeper. So what are some patterns we can see in those relationships? Those are indicated in this insights section. So in the insights, you can see a lot of the uh, content has three citations. Many of them might have four. I have seen it go till 12. So it draws the patterns among multiple relationships that were drawn within the entity. So as mentioned, just a quick, what we do is we take the data, we break it down into chunks, we go even to the like a word or two-word level, we convert it into decimals, and we connect those decimals from some paper to decimals of other papers. We make those connections. Okay, so for example, this experiment is related to this experiment, and we build those knowledge graphs and clusters. And it's very complex to build, but it's okay. So, and those kind of relationships, those kind of clusters allows us to give this kind of detailed, granular, insightful information that is uh, very useful for us, to be honest. And implementation, so those were insights. We also give implementation, like how you can build it. You want to test it yourself, I'll tell you how you can build it. So this is, as you can see, like the whole implementation, required tooling, choices, why, what tools would you require to build this, right? Like how can you compare it yourself? So phase one, what codes would you require? What functions you would require? What libraries you would need? Phase two, single agent baseline, implement, like implementing single agent, implementing multi-agent. And we know that these things would be built would be done by researchers. So keeping those resources in mind, this whole thing is tailored. We won't recommend like something like you need to build a data center first, for example. We won't say that because we know that the user who is using this should be able to do it. Now we also have experiments, because I know what prompt you asked, what is your main query, like the user's query. We also suggest you what kind of experiments you can run to achieve this kind of insight or observation or anything you want to achieve, right? So related to the query. So we have given you 5 experiments. You can like read it through, and again, none of it is none of it is generic, because the apparently the generic problem was because of the n- non-existent of relationships, like because relationships were not existing. Those is the that is the problem of generic answers. But because we have built the relationships, none of it is generic. You can see we are drawing many experiments conducted into research papers. We are combining best parts of it, building it our own, because we know which kind of experiments usually work well and can be executed by the researchers, and combining it that with the entity's help, and suggesting experiment. You can also click on generate code. So not only we are just suggesting you, we are giving you the platform where you can see the code of the experiment and even run it. Not just see it, but you can run it. So just to give you more surety of how it works, and because we have access to the entities, there are better chances of we giving you the code than you figuring out where the code is, how should it work. It's like a scaffolding, because okay, so everything we did in this, we know how the researchers work. First, they would research a lot in the first year. They would read a lot of literatures. They would do a lot of literature readings. Those part, is in findings, observations, and insights. We know those things will help you over there. After that, you narrow it down to 2 to 3 research papers. You probably choose a research paper which is at 30%, 40% accuracy, and you try to improve that kind of research paper. To do that, you need experiments. Now, why do you need experiments? Because you try to use experiments conducted into other papers, and try to replace your literature reviews experiment with those kind of experiment. You just try to do that to figure out a way how you can improve the accuracy to 65%, let's say. So at those in those time, you need a scaffolding. You start off with scaffolding at least. So this is the scaffolding that we give for the experiment. So this is the experiment, and you can see we have given you the code. Okay, so this is the like a whole code you can see, and even you can edit it. You can click here, you can press enter, you can press whatever the code is you want. Okay, and yeah, you can write the whole code, and you can edit it, and you can click on run code even. So you can even run it, and because we know it is designed for AI researchers, it is not running on a CPU. It is running on a GPU. So we have got NVIDIA L4 GPU, serverless, obviously, and it allows us. Okay, now you can see the code is running over here. Okay, and once the code is like the whole it is complete executed, you can see the explanation of what happened in the code, why did it happen, how you can fix it, and you can even here we have AI code editor. Like you can click, you can say what you want to edit in the code, and we will edit the code accordingly. So yeah, so that is for the experiment side. Like this is the like whole end to end how you can conduct experiments. This is fun actually, research papers. So I'll go into detail of how the research paper works in the next video that I'll share it with you. But because this is more on deep research, I'll focus on that. But yeah, I'll just skim through it. Like this is the research paper, and now every particular choice was indicated by the researcher. For example, why did we choose abstract introduction methodology? The reason is while reading research papers, researchers first read abstraction, introduction, and methodology. They prefer reading this, then they decide if they want to go deeper into that paper. So we know that, and that's the reason we have kept the 3 columns, abstract, introduction, methodology, and these are the papers. Now, as you can see, this is a whole different layout of reading a research paper. This is not how research papers are being like our people are not used to reading research papers like this. This is a whole different architecture, a whole different layout to read research papers. You can see abstract, introduction, methodology. If you don't want to see that, you can just unclick that, and let's say you want to see funding. Who funded this research? And you can see here alignment research from Ashgrove. Research was supported from funding in the government research grants and everything. You can see like the whole Applied Sciences, Northwestern Switzerland, Imperial College London, research grants, Shanghai Key Laboratory of Data Science. You can see who has funded. So any button you click over here, you can see those part of it in the from the research papers. You don't need to click and read the whole thing. We have used it, we have summarized it, we have made it way more easier for you to read it. You can even add a new column. For example, what experiments were conducted in this research paper? Explain it like a Christopher Nolan movie. Okay. Now, as you can see, I gave this prompt, right? It was added as a column. And it's very interesting. It is added as a column. And now you can see the model is reading the research, the entities, the relationships, turning it into a Christopher Nolan movie's analogy, and it is giving it to you. So now you can read it like a whole new. In this research, a series of intricate experiments unfold like a Nolan movie where the stage is set with simulated marketplace, a digital arena of high-stakes trading. Imagine a world where AI agents powered by advanced language models take on the roles of sellers and buyers in a relentless double auction. These agents are not mere algorithms, they are characters with movies capable of communication, strategy, and deception. The experiments are like scenes in a complex plot. So everything is done like a Christopher Nolan movie, apparently. So you can explore research in a whole new way. It's not jargons and technical the way it used to be. It shouldn't be like that. So yeah, so that's how the research papers work. And you can see, you can read, there's TLDR, too long didn't read. and you can read all the research papers like this. We have export option, so you can even export the content that you found in this table you found useful. You can export it. I'll show it in the next video. And we have portal. Apparently, the main problem that we figured out, and also I was also facing this problem, is uh, access to solution is not the problem. The problem was asking right questions. Like people thought they were asking right questions, but it led to the dead ends. So asking right questions was very much important in terms of research, in terms of going in the right direction. So yeah, many researchers were scared actually that they might um, not ask the right question, and which, so yeah, it was, so we tried to solve it. What we did, we divided the whole output into certain kind of components, and we designed an architecture separately for this questions part. Like what questions should a researcher ask in this component to go in the right direction, considering what the prompt was. So you can see there's a lot of questions that we are giving to the researcher. It's not just one, two questions. There are a lot of questions, and each one is, for example, can hybrid designs leverage strengths of both? Design framework, when to choose single agent. Okay, so these questions are for design decision framework, for example, when to choose single agent or multi agent. So, for example, I want to understand, is explainability a factor in architecture selection? So it says click to deep dive. I just click on it. It goes into a new tab, and it is asking which mode do you want. And let's say I want Lone Scout. So this is, again, you can get the idea of how Lone Scout works, right? So here you can see I just clicked once, but we designed a system where a whole prompt is written. What role does user or system interpretability play in choosing between architectures? So it's amazing that user didn't type whole this, user just clicked on one thing and the prompt was given by our system. So we gave the prompt, the research is happening, 100 research papers are already being read, and so you get the idea. And okay, now we can go back to where we were. So as you can see, we have got the output for that Lone Scout one that we did. And yeah, and this was the main research that we were reading, right? So this was the portal where you can see the questions. We also give you the videos that might be relevant for you, considering we know what you asked, right? So these are the land graph, for example. This is a multi-agent architecture, beginner's guide to agent evaluations. And we give a lot of videos for you where you can just read it, and there is no need of you going on YouTube and finding the right kind of videos. You can just watch it over here, and because again, you don't know what you don't know, right? So we have narrowed it down. You can just watch it from here. You can go on YouTube with the same one click, and yeah, it will play over there. This is the history. For example, I just clicked on the new that thing, right? The dive portal. So it is adding over here. This is summary, and these are the sources. Okay, so for us, it was very easy just to give sources, right? But what we did, we know that this product is designed for researchers. So researchers don't just want the source, they will also would like to cite it. They would like to see the whole details of what the source was. They would like to see the full analysis of how confident the source is, and they would like to see the citation of it. So instead of going outside and doing it, we have just added all that, we have integrated that. So with just one click, can generate it, copy it, and done. So sources has that. We have given you GitHub. We are giving you repositories of related projects that you can view, you can see, you can conduct experiments, you can connect with, and you can just click on it, and it leads to the GitHub pages where you can see, for example, LLM agent benchmark list. So whole experiment is over here. So as of now, I don't think there were any patents. So we there are zero patents. But if there were patents, you can see it over here. And on GitHub, you can also even search. You like, for example, I just typed LLM, and it will show you all the projects that were related to LLM. It takes few seconds to find the projects. Okay, boom, we have the results. We have 50 results of GitHub repositories of LLM. So we have developed a different search algorithm for GitHub to find these kind of projects that are, for example, Mustr. The name is Mustr, but how can you know it's related to LLMs, right? So yeah, so but again, we have developed it, so that's easy, and that's easy for the user. And yeah, so this is how the deep research works. So as you can see, all of these things you got it with giving just one prompt. Just asked for comparing single agent and multi-agent, and you got all this information. How, what is what's the comparison, observations, insights, implementation, how to build it, experimentations with the code. As you can see, even the code has been executed till the time I was showing the other things. So there were some errors. You see there were some errors. You can see the explanation. Okay, like what were the errors, what happened. So the explanation, you can see it over here, the purpose, what was the experiment, how was it done, everything, you can see it over here. It's just beautiful. You can see it. Um, it's even given you implementation details, like why did it use certain things and why not. Like CUDA was like the NVIDIA's GPU's name is CUDA, so that was preferred. So yeah, and we give you the research papers in a whole different way. So this way you can read 100 research papers. But if you are familiar with Google Scholar, it's very difficult to read over there, right? So you can see H index, venue, author, related papers. You can see even related papers to the mentioned research papers, portals, videos, history. The more deeper you go in the findings, the history gets more complicated. Okay, I can more nodes are there in the history. For example, I see this formula and handling multi-step and complex reasoning. So single agent address complex queries by breaking problems into sequences of incremental reasoning. So and tools in for on the other hand, leverage specialization and collaborative interaction, manage complexity more effectively. So let's say I select this part and I want to understand how this works. Like I don't understand it. I want to go deeper on this. This was not deep enough for us. So we just click on this dive icon that you can see here, and the dive icon is loading currently, and I'll show you how it works, what's happening. So as you can see, we we understood what kind of line you selected, and we know what kind of prompts can be are suitable for that line. So we are giving you few prompts that you can just tell us where you want to go with it. For example, what do multi-agent systems leverage to manage complexity more effectively? How does collaborative interaction benefit multi-agent system? So these are the most accurate prompts, which will get even better with the usage, because it's like proprietary to us. And you can see these prompts. You don't need to type it. You just select whichever you want. You click it, done. Boom, it's searched. And again, we have rewrote the prompt more effectively, so you don't need to do it. You just want with one click, it is done. And we can go back here, and you can see the whole thing. So everything is click driven, no prompts. It's not that we don't have prompts. It's just that you won't need prompts over here, because everything is covered. There is no stone left to uh, turn. So yeah, so this was deep research. And in the next video, I'll show you how the research papers and how the experiment works.